Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last lecture of this week 2 for this ongoing online course on understanding and reducing greenhouse gas emissions, focus on scope 1 and 2 emission reduction through building design and construction. I am your instructor, Professor Avlokita Agrawal. I am an associate professor at Department of Architecture and Planning, IIT Roorkee. Here in this lecture, we are going to talk about carbon footprint and its calculation. So, we will try to understand what carbon footprint is and how do we really calculate it, because that is something that is going to take us to the GHG protocol. So, before we really start working on understanding GHG protocol, what are the scope 1, 2 and 3 emissions and then how we reduce them, we have to quickly understand what is carbon footprint and how do we calculate it. In the previous lecture, the fourth lecture of this week, we had understood what is greenhouse gas effect. We understood what are the characteristics of greenhouse gases, their concentrations in the atmosphere and their impacts on the greenhouse gas effect. And there we clearly saw a direction emerging that what we need to do if we have to reduce the greenhouse gas emissions. So, taking from there, in this lecture, we are going to understand the definition and the related concepts of carbon footprint. Going on to carbon emissions, how to reduce carbon footprints and how to calculate carbon footprints. So, not absolute numbers, but an understanding of what all will be included, because it is a very complex phenomena, which is what we will get to know. So, let us start with this lecture with definitions and related concepts of carbon footprint. So, by definition, a carbon footprint is a certain amount of gaseous emissions that are relevant to climate change and associated with human production or consumption activities. So, this carbon footprint could be for a product, it could be for an activity, it could be for an entity, it could be for an activity. This is what we are talking about, and usually it is expressed as carbon dioxide equivalent. So, if you remember, if you refer to the previous lecture that we had, where we took the GWP of carbon dioxide as a gas, one molecule of that as 1. So, if we look at the footprint in terms of what all kind of greenhouse gases will be emitted when an activity is being performed or a product is being manufactured, and then we would know that what all emissions have happened, and we will equate that to the equivalent carbon dioxide that is emitted, and then we will equate it to the tons of carbon. Sometimes it would be carbon and sometimes it would be carbon dioxide equivalent. Different organizations and different standards have different way of addressing, but at the end of the day we are looking at an equivalent carbon. So, for example, if we are talking about fluoride gases, there the carbon molecule, the weight of carbon molecule could be lesser and the impact of fluorine molecule will be higher, but yet we are looking at the equivalent of carbon. So, it is not the real calculation that how much of carbon is really being released in the atmosphere, it is the equivalent. So, the actual numbers would actually be for the fluoride gases or CFCs or HCFCs, but equivalent how much of carbon or carbon dioxide is being emitted into the atmosphere is what we are going ahead with. If we go by what IPCC uses as the definition, the carbon footprint is a measure of the exclusive total amount of emissions of carbon dioxide that is directly and indirectly caused by an activity or is accumulated over the life cycle stages of a product. So, they are talking about the total emissions of carbon dioxide, and we usually talk about carbon dioxide equivalent. So, this is as per the definition. Now, this has emerged, or this is a subset of a bigger concept which is ecological footprint. So, when we are talking about carbon footprint, we are actually talking about the emissions due to an activity or manufacturing of a product which is calculated in terms of carbon dioxide equivalent. but we clearly know you already have seen activities and products being manufactured around you, and we see that carbon dioxide or greenhouse gases are not the only resource, are not the only gases that are being emitted, or they are not the only resources that are being consumed. So, fuel is not the only resource that is being consumed. We consume water, we consume land, we consume food. So, a lot of these things we consume a part of forest, the timber could be there. All this is calculated, considered under the ecological footprint. So, it is not just energy or carbon that we are talking about. Under ecological footprint, we are talking about, yes, energy, but we are talking about land, we are talking about timber, we are talking about food, water, everything. So, we are talking about basically the resource providers. For example, we are talking about cropland and pastures, we are talking about forests, we are talking about water bodies, lakes and oceans. This is the ecological footprint of an entity, an activity, an individual or a product that we are talking about. So, carbon footprints which we have seen, they are represented as carbon dioxide equivalent per year, but ecological footprint is measured in the number of earths that this particular activity would require if everyone on the planet consumed the resources at the same pace as this particular activity or entity. So, usually ecological footprint is for entities, it is for organizations bigger. For individual, of course, it is a culmination, it is a combination of all smaller entities within that bigger entity that we use ecological footprint. So, for example, ecological footprint of countries, within a country ecological footprints of states or cities is what we usually use, but carbon footprint we use for smaller entities. For example, an industrial plant or a company, an industrial company, a multinational company. So, what is their carbon footprint? Or gradually we move to accounting of carbon footprint or the greenhouse gas emissions, which is what we are going to look at. But when we say ecological footprint, we are talking about water footprint. How much water do we consume? Energy footprint, the forest footprint. So, that is what we are covering in ecological footprint. Now, when we are talking about carbon footprint, what is required? The requirement is that we account for it. Now, we can't go about saying ki my carbon footprint is this much. How would I know that if I have eaten one chapati today versus if I have eaten a plate of beef today? So, what is my carbon footprint? How do we know that? There accounting is necessary. So, there have to be some benchmarks. Now, they will depend upon what process has been used. For example, if I produce a bag of wheat using industrialized agriculture, where a lot of machinery is used, a lot of energy is going in, versus I consume a bag or I procure a bag of wheat which has been produced organically and without the use of a lot of machines on the farm, the traditional ways of agriculture, what is the carbon footprint? And then when I consume that, what is my individual carbon footprint? So, that is what we are going to do, we are doing when we say carbon accounting. So, carbon accounting or greenhouse gas accounting, which we commonly know as, it is a framework of methods to measure and track how much greenhouse gas an organization emits. So, this is what has led us to the formation of greenhouse gas protocol or a lot of similar calculators and tools where we have tried to kind of benchmark certain activities, because we can't go ahead and just say that this particular and can't calculate it from scratch every time. So, different organizations, researchers across the world are working on carbon accounting for different activities. For example, I was talking about reducing the requirement for HVAC, and how do we do it? We make the buildings comfortable. All of you, wherever in the world you are, you must have seen the traditional buildings being built in that manner, that they require least amount of energy and still maintain comfortable indoors. You go in extremely cold climates, they have very thick walls. You go to extremely hot climates, the deserts, they have very thick mud walls. Now, compare that with a multi-storied building which is using glass as a material. So, thick mud wall and a thin glazed facade. We have to do the carbon accounting, carbon footprinting of both these buildings. Both are buildings, both are serving probably the same function. So, there are two parts. One, how much of carbon the manufacturing or construction process for this material, which is say mud, has produced, versus how much of carbon has been released, carbon dioxide has been released during the production of glass as a material. That is one. Two, when we are living in this particular, when we are occupying this particular building which is made of thick mud walls, what kind of indoor environment is there? How much energy do I consume when I have to maintain a comfortable environment inside is also a part of it. So, it is embodied as well as operational energy, and here how much of the operational energy will I require, and we are not even accounting here. So, this is direct release of carbon dioxide due to the energy that is being consumed, let alone the consumption of chlorofluorocarbons or HCFCs in the HVAC unit, which I am going to use when I am occupying a glazed facade building. So, carbon accounting is largely looking at the direct or indirect carbon dioxide emissions or equivalent to carbon dioxide emissions. That is what carbon accounting is doing, and a lot of benchmarks for different geographies are being created these days. So, it is only becoming more and more robust, the tools are becoming more and more robust, and GHG protocol, greenhouse gas protocol, which is what we are going to see in starting from next week onwards, is a form of carbon accounting. It is a type of carbon accounting method. Now, coming to carbon emissions. So, there, just as I mentioned in the example of a thick mud wall building in a desert versus a glazed facade building in the same area, we are talking about embodied carbon. So, the amount of carbon that would have been released when the material to be used for construction was being manufactured, and not just manufactured. So, starting from the extraction of it from the nature, the natural resources, till the delivery of that particular product on construction site is what the embodied energy of that material would be, and then embodied energy of construction would be when we use that material in the building and construct the building. So, this is all of this is part of the embodied energy of the construction that has gone into the building. Now, when we say life cycle, so there are different definitions and different understandings of this life cycle. How much will be the life cycle, and when we are doing carbon accounting also, and whenever we are doing life cycle analysis or life cycle energy analysis, life cycle cost analysis, this definition of life cycle becomes very critical, that how much and what is my boundary. So, defining the boundary, that becomes critical, and we need to discuss on that. Now, if I am comparing two students of mine who are living on the IIT Roorkee campus, and I compare their carbon footprints based upon the lifestyle that they have here. So, what have I defined my boundary as? I have defined my boundary as IIT Roorkee campus living only. Now, what they do, when a student is coming to the campus, he is coming by air, or he is coming by road, or he is coming by train. I am not taking that into account. I have defined my boundary only as this small boundary when the student enters the gate of IIT Roorkee. I can define it that way, and then how the student lives here, how is his lifestyle. For example, there is a student A who consumes only vegetarian food, there is a student B who consumes a lot of non-vegetarian products. What are the differences in their carbon footprint due to the lifestyle choices that they have, the number of clothing pairs that they own, the kind of expenditures that they have on with different type of activities, all of that is carbon accounting, but within this boundary. Now, I can increase this boundary, and I can include it that when he starts from his home and he stays here on IIT Roorkee campus, there I will also include the way he is commuting, the transportation. I may increase it bigger. When he stays at his home, what kind of lifestyle does he have? So, the boundaries can be set, and they are totally dependent upon what is our objective. So, depending upon the objective, we define the boundaries for the life cycle analysis or even carbon footprinting or for any accounting method. So, that is what we have to do right in the beginning of any accounting method when we are talking about the carbon footprint or ecological footprint or life cycle analysis. Now, coming back to the greenhouse gas emissions, because that is our major focus, we have already seen in the previous lecture also that the major contribution to emissions is because of the energy sector. So, today the maximum amount of emission is being released because of burning of fossil fuels, and that is for generating energy, that is for generating electricity. Now, if we look at emissions by countries, and if you remember what I was talking about in the previous lecture, where I said that it is about per capita consumption of energy multiplied by the total population. So, if you look at this particular graph, you can see here, so there is this number written US 14.4, China 7.1, India 1.7 and Africa is 0.7. These are the per capita consumption numbers that we are getting. Highest is in the Middle East where it is 19.5. Now, how is the width varying? So, what we have is this is the population. So, this is the population of a country, and this is how it represents. The wider this quadrant, the more is the population of a country. Now, this is the depth, measures the per capita consumption, and this width gives us the population, total population, and the area gives us area of this. For example, if I take US, so the total area gives us the total energy consumption, and if you look at that, the total energy consumption of India and several others underdeveloped or developing countries is way lower. So, despite having large populations, they have an overall energy consumption which is much lesser than the developed countries. Some of the developed countries are at real advantage because their populations are much lesser. So, if you look at cases like Canada, Canada has a per capita consumption higher than United States, but it has very less population, very high per capita consumption, but it also has huge amount of resource which is available. However, they might be having large amount of resources available to them, but it does not entitle any country for that matter to consume all those resources by themselves, because it is a shared world and it is a shared responsibility. Now, here we are talking about the shared responsibility of reducing greenhouse gas emissions, and that is why we are moving ahead for greenhouse gas protocol. So, this is what I was explaining in the previous lecture also, how emissions by country are affecting. Now, we also have to understand emissions by product, which products have higher emissions. Now, you must have heard and read a lot of discussions which is going on around in the world, but the moment we started to account for the real numbers, their carbon footprint and the emissions that are taking place, and here we are also talking about, we are considering several steps during the life cycle. For example, we are considering the land use changes that are happening. So, for production of a particular product, if large areas of forest land have to be cleared and they have to be converted to accommodate for that particular activity, so we already know that deforestation also releases a lot of carbon dioxide emissions. So, land use changes, farming, animal feed, processing, transportation, retail, selling of the products and packaging, all of that and the emissions due to each individual step is accounted for. It is taken into consideration when we talk about emissions by product here. You will be surprised to know, and there are a lot of products here. We are talking about food products particularly. If you look at food products, nuts particularly, they have negative emissions because most of the nuts are actually procured from trees, full grown trees, and they sequester a lot of carbon. So, we know that nuts are rich in oils, most of them hydrocarbons. So, they store a lot of hydrocarbons in them. So, nuts are actually negative. And then if you look at all the vegetables and vegetarian food, we are talking about unprocessed food here, this is what we are talking about, they usually have very low carbon footprint. They have very low emissions here. The moment we start to process, for example, sugar, we have slightly higher. So, natural products, natural food products, and if we look at how the products are sold in different countries, it will also have different emissions, different carbon footprints. If you go to a mall in United States, you would find that each individual fruit, which is a natural product, is packed in a plastic cover. So, each individual fruit is packed, while if you go to India, we will go to a vegetable market, a sabzi mandi, which we know of, and we will find that none of the fruits or vegetables is packed. That itself removes one step here and a lot of emission due to that product. One apple here in India and another apple to be procured from a mall, a supermarket in America, will have different carbon footprint. But this particular is from United States, and looking at that, considering that each individual fruit or vegetable is also getting packed, we will see that processing will add a lot of emissions or carbon footprint of that particular thing, and then starts dairy and meat products, and which suddenly jump high. So, milk, when it is not processed, is here, and the moment you start to talk about non-vegetarian food, wild caught fish is the least here, which is what you see here, and then highest being beef, especially the farmed, produced on a farm, that kind of beef, lamb, they have very high carbon footprint. So, our choices, whatever choice that we make, from starting from the food we eat, the clothes we wear, the kind of transportation that we take, the kind of building that we are living in, the kind of lifestyle that we have, is contributing towards emissions, and it is contributing towards our carbon footprint. Now, how would we reduce carbon footprint? So, what I just showed you, it is about choices. It is about the choice of food, water, clothing, transportation, everything that we have to select. If we look at the global perspective, and which we have seen in the Kyoto Protocol and Paris Agreement also, currently what the world has set, different countries have set as a target for themselves, we are not going to reduce the greenhouse gas emissions. And if we really need to shrink the carbon emissions and to bring it to the level where we have to limit the global warming by 1.5 degrees of pre-industrial levels, we will have to shrink the carbon emissions by a rate 10 times faster than we have committed. We are not achieving that as well, the commitment, but if we really have to reduce the global warming, we have to increase the space 10 times faster of sequestering the carbon emissions. And personally, what we can do, this all of you must have already known, you must have read everywhere, we have to refuse, we have to reduce, reuse, rot and recycle. So, what do we refuse? We refuse the products such as single use plastics, which directly go to the wastelands, and we have already seen how wastelands are contributing towards greenhouse gas emissions. Reduce, we downsize the purchase. If I need one, I purchase only one. I do not purchase anything that is extra or unnecessary or might not be needed. Now, here there is a huge debate that how much is enough, how much is what I need. So, need versus what I want, what I need versus what I want is a whole debate. How many pairs of clothing do I need? How many pairs of footwear do I need? How many pairs of glasses do I need? It has to be clearly argued, debated, that the needs do not have to become wants, is what we are talking. It is philosophical at some point of time, but then the whole idea is that we reduce the consumption, the resource consumption, only consume what we really need and not want, and then we reuse. So, we always have to find a way to keep reusing the items. I am very proud of this fact that in India we have this inherent, and we had for a long time, and now we are getting influenced by a lot of cultures across the world, and we are refusing to reuse the product, but earlier we would reuse the product till it is an absolute waste, and we would continue to reuse them in different forms. You can go around your homes, especially talk to the older generation, especially the grandparents generation, and you would see that, oh, they wouldn't throw anything. So, a lot of times people complain that Indian homes are quite cluttered. That is because of the philosophy, the inherent philosophy of reusing, and that is why we have remained a sustainable society for a long period of time. We had no issues of waste until very recent, when we started to refuse, or not refuse, rather send things to waste, single use plastics, polythene bags, and a lot of things which are disposable. Anything that was earlier to be disposed of after single use was made out of organic products, for example plates. So, if it was a single use stuff, it was made out of leaves, it was made out of grass, that is what we would do. Unlike now, where we are making out of plastic, we are making it out of synthetic products like thermocol and other things. We would never use products which are to be thrown after single use, and we would most of the times reuse the things. Rot, so we have to set up composting systems to compost the food scraps or all the organic items, and finally we have to recycle. So, things which we cannot decompose, which we cannot reuse, or we have reused enough, we have to learn to recycle them. So, they have to go to proper plants, we have to put them in plants, recycle them, and then manufacture more products out of that. So, this is to personally reduce the carbon footprint, and each of us has to become conscious of what our carbon footprint is. And it is unfortunate, but actually the climate change is primarily being driven by the behavior of a very small population of world's richest people. So, 10% of the richest people are actually responsible for 50% of the total emissions of the world, and it is largely lifestyle emissions that I am talking about, and the rest of the poorest 50% of the population is responsible only for generation of hardly 10% of the total lifestyle emissions. So, all of us who are capable of affording certain lifestyles have to become aware of reducing this carbon footprint at an individual level. Of course, at a country's level, at a systems level, we have to talk about a central accounting system, which is what we will see, but personally we have to reduce our footprints. Now, how would we calculate the footprint? So, the footprint, carbon footprint, is actually the amount of greenhouse gases that are emitted or removed or embodied in life cycle of the product. So, we have already talked about the life cycle, and it has to be estimated and added. So, we are talking about all the greenhouse gases that are emitted or embodied in the life cycle when we talk about GHG accounting. Now, when I say all the greenhouse gases emitted, not all the time all greenhouse gases that are emitted or removed are taken into accounting. Sometimes it is only carbon dioxide or carbon dioxide equivalents or only carbon. So, that is what each tool will vary. So, sometimes they will consider only carbon dioxide, sometimes they will consider all greenhouse gases and equate them to carbon dioxide. So, different tools address it differently. So, there are several standards and guidelines that are available for GHG accounting. I am not going to go in detail over these because we will be taking this particular part in the next week, where we will be going over each one of these, some of these, and we will be dealing with them in detail. So, what we are going to read in detail is this GHG protocol, greenhouse gas protocol, which was developed by World Resource Institute WRI and World Business Council on Sustainable Development WBCSD. So, it provides a framework and a basis for most GHG accounting. So, it includes the ISO 14064, which is an international standard for determination of boundaries. So, I talked about the determination of boundaries, which is essential. and then quantification of GHG emissions and also the removal. Then we also have PAS 2050, which is publicly available specifications. This is British standard. This is from British Standard Institution, and it specifies the requirements for assessing the life cycle GHG emissions. We also have the 2006 IPCC guidelines for national greenhouse gas inventories. So, as I said that we have to have inventories, and different countries are developing more and more inventories. It is a complex system, and every time I say that, we are talking about limiting the global warming to 1.5 or 2, or we are talking about overall greenhouse gas emissions and this and that, these are coming from different models and of course some experiments also. So, this, because there are so many parameters, we are talking about an entire planet here, and when we are talking about even the smallest of an entity, we are talking about hundreds of processes that are driving that. So, it is often difficult, and each of this will require an inventory. It is not practically possible to accurately give or account for the greenhouse gas emission, but we can come very close if we have a wide base of inventory. That is what is being done. We also have ISO 14025, which is a standard for carrying out life cycle analysis, and 14067, which is a standard on carbon footprints of products, and it is still under development. The inventories are getting made. So, some of these we will read in upcoming lectures of the week 3. When we are doing the footprint calculation, the GHG data, as I said, are translated into carbon dioxide equivalent, but not always. Sometimes it would just be taken as the carbon dioxide that is directly released, or the carbon that has been released, or the equivalent of that. So, and then here we are talking about the so its boundary plus a timeline. So, for a building, the lifespan could be considered to be, say, 50 odd years, but a solar panel, it could be considered only as 20 years or 25 years. For some other activity, for example, if we are constructing a dam, the lifespan could be considered as, say, 150 or 200 years, depending upon what is the material of construction. So, different projects would have different lifespans, and we would calculate the carbon footprint for that entire lifespan. So, it is the boundary and the lifespan plus the inventories of all components that go into this. So, this is what will the footprint calculation usually requires. There are many carbon footprint calculators across the world. This is one very good reference that you can go through, and you can read about several carbon footprint calculators that are available. So, we have a lot of calculators from the USA, Conservation International Carbon Calculator, Climate Change Calculator, Greenhouse Gas Calculator. Several developed countries have developed the calculators, but primarily the parameters that are accounted for in these calculators are often the household, the energy consumption, which is definitely a fair thing to do, because energy is the major contributor to greenhouse gas emissions, which we have seen. Then personal accounting of carbon footprinting. Then we are also talking about the transport, and of which air travel has been significantly considered in most of the calculators. So, this if you see, so in most of the calculators they are considering the air travel, and then the food that we consume. So, some of the calculators do not take into account foods, but some of them do. So, for example, here you can see that this particular calculator, which is climate change from USA, does not take into account the food. This one from Australia, greenhouse gas calculator, also does not take into account the emissions due to food and waste. An inconvenient truth carbon calculator from USA again takes into account a lot of these parameters, and usually most of them are actually calculating the carbon footprint in tons of carbon dioxide or carbon dioxide equivalent per year. There is another one from UK, which is Acton's carbon dioxide. This is also taking a lot of parameters into account, but not the food and goods, services and waste. So, this is a vast array. A lot of calculators are there, interesting calculators. One thing that I would request all of you and urge is to follow, and most of these have good inventories. A lot of times most of the calculators are actually depending upon the common inventories which are getting developed as ISO standards. So, they are basing their calculators on the existing inventories. So, the inventories at the base are more or less same. You can use any one of those calculators and try determining your own individual carbon footprint as you go about your life every day. So, the moment you make different choices in the calculator, you will see how your footprint is varying. You choose to eat a certain product, you choose to buy a different pair of clothing which may be manufactured in an industry versus the one which is manufactured by hand on handloom or through handicraft, there will be a significant difference. So, this is something that all of you should do and start doing from now. You can go through this paper and you can go through these slides which will be made available to you as transcripts of this particular course and lectures. You can go through these individual tools. There are websites which are mentioning what and where these calculators are available, and you can also see that what are the inventories that have gone in. So, most of the calculators also mention that which inventories have they used. So, you also need to talk about understand what inventories, where inventories are being developed and which inventories are also going to be used. So, this is all in this particular lecture, and one more thing before we close, we can use footprint calculation, carbon footprint calculation for varying scales and different entities, starting from individuals going all the way up to nations. We can do carbon footprinting. When the scale gets bigger, we will switch to ecological footprint. This is what we are going to do with carbon footprinting. So, this is all in this lecture. Thank you very much for being with me in this second week of this ongoing course. In the third week, we will start with greenhouse gas protocol and we will start understanding what are the different scopes of emissions that the protocol talks about. And gradually moving on, we will learn how to reduce the scope 1 and scope 2 emissions, and we will also talk about why we are only talking about scope 1 and scope 2 emissions and not really scope 3 emissions as part of this course. So, thank you very much for joining me in this week of the course. See you again next week. Bye bye.